everyone. Thank you. Welcome back to Science Data Analytics track. And the next person we've got speaking is Dr. Tania Allard, who's going to be talking about DevOps for data science. Definitely not the DevOps. That's happening in a totally different room. Now, Tania is a senior developer advocate at Microsoft, focusing on machine learning and scientific computing. And she's passionate about mentoring and community building. And I'm just going to let her talk for herself now. Go ahead, Tania.
Thank you very much for the kind introduction. And I am very, very happy to be joining PyCon Line Australia this time. I've been wanting to attend PyCon Australia forever, well, maybe someday. And my name is Tania Allard. As I've been introduced, I'm going to be talking about DevOps for data science, or how you can automate boring and nitty-gritty stuff and leverage the open source ecosystem. I'm going to be at the conference today and tomorrow. I'm UK based, so my times are not exactly the same. But if you want to reach out after my talk or after the hallway track, you can find me on Twitter, GitHub, or there is my website at the bottom, and there you can find all of my contact details and stuff. Just a tiny bit about myself to give it about of introduction. I absolutely love Python. I use Python every day in and day out. I imagine like many of you folks. I'm also a Google developer expert for TensorFlow and machine learning. I love mechanical keywords, so if there are any other mechanical keywords enthusiasts in the conference, I would love to talk about that. And just as a disclaimer, my dog seems to have like the perfect timing, and she sometimes barks when I'm giving online talks. I've tried to distract her today with a new different kind of toy. Let's see if that works. And as usual, my slides are going to be available after the talk at this link. I'm going to put it back again at the end of my slides. It's not ready yet, but I just need to click publish and you'll be able to access them. Everything is CC BY, so you should be able to use, reuse, and remix. And just to give a bit of context about what I'm going to try and cover in this 25 minutes, well, more like 23 minutes now. First, I want to give a background about the status of machine learning and data science in 2020. And then move on to what is MLOps or DevOps for data science and why you might need it. And finally, I'm going to close with some getting started tips with MLOps so that you can start automating stuff in your workflows. So let's get started with a bit of background. I don't know if any of you are familiar with the Gartner hype cycle, and this is normally a cycle that new tech or new tools or approaches normally follow as it goes out into the wild. And it seems that now machine learning and, well, I'm going to say machine learning, artificial intelligence, all of that has gone through a lot of these stages. We've been through the early adoption phase, we've been through the negative press around AI bias, all of those very contentious articles saying that AI is going to steal your jobs and pretty much take control of the world. There are first, second, third rounds of venture capital, and I think we are now actually entering the point of high growth adoption. So we're gonna sure probably in a couple of years, hopefully entering the productivity plateau in in all AI and machine learning. So it's not uncommon to go and see different teams now, or whether it's a small company or a big corporation or a research institute, where you have the data scientists very, very excited because it's now super easy to run machine learning experiments. The development and the open source ecosystem, we have amazing things like scikit-learn, TensorFlow, PyTorch, and everything is just Jupyter Notebooks. Everything makes it so much easier to get started and start iterating and doing research and development. But then on the other side, we have the machine learning engineers or SRE engineers or software engineers that are trying to actually take those machine learning products, put them into production, or get them out to the customers or to the business. And we still find that it's hard. It's very, very it's not straightforward to do this. In fact, there are a lot of papers, a lot of studies, state of the art in machine learning, that says that a very, very small portion of the business that are experimenting with machine learning are actually seeing the benefits because of this big wall from taking something that is into R&D to something like fully usable or productionizable. So let's go again and look at our data science. I mentioned it before that we have amazing things like scikit-learn and keras. It is so easy now with using things like keras to create models in a few lines. You didn't have to spend a lot of time building all of your models from scratch or specifying each layer in your neural network. We also have amazing techniques like transfer learning, which makes our lives easier, and it allows us to build on pre-trained stuff that other folks have spent a lot of time and compute on. And talking about compute, we have a lot of compute at the finger of our tips. If you're using the cloud, you can easily have access to GPU compute or GPU-enabled VMs, and that definitely helps you to streamline and optimize your workflows from the computational side of things. But again, over all of this hype of machine learning, AI, deep learning, everything, we've always seen that a data scientist or a machine learning folk has to be a unicorn with data visualization skills, software engineering, analytical programming, data engineering skills. But now for them to be able to take things to the next level, they also have to know things about CI and CD, deep learning, privacy security, containerization. So actually, there are a lot of articles as well that I've seen coming out in the last few months or even years, saying that folks or data scientists should become a bit more of a generalist or like front end, back end, data science. Vicky Bokis, that is one of the people I admire the most, and I really, really love her insights in this area. She actually recommends folks that are interested in entering into the machine learning world to go down the route of machine learning engineering, because we need a lot of machine learning engineers. And here is where the whole MLOps processes and approaches actually enter into play. If we go a bit back and try to think about how this whole DevOps practices started in software engineering, it was because we had this apparent opposing interest or needs from software developers and operation teams, where software developers needed to move and iterate fast, had to test their code really, really fast, be able to put things out there in production easily. But operation teams are always a bit more concerned about stability, availability of the services and the whole infrastructure. So it might seem at a first glance that these are opposing interests. But actually, the surgeons of DevOps puts it into a place where it brings together people, processes, products, tools to enable the continuous delivery of value of whatever you're producing and putting them into production. And this is probably one of the best, this is always the definition of DevOps that I go back to, because it highlights the importance of all of the players and all of the things that have to come together to bring these practices to fruition in your company or your research institution. And DevOps revolves around three main principles. The first being automation. Try to automate as much as possible. And as you're automating, you can get feedback in a much faster fashion. So if you're testing your code on push when you're pushing to your version control or your servers like GitHub or GitLab or Bitbucket. As soon as you push your code, you can run your automated test, do all of your set of testings, and get feedback. So you can actually say if the test passed or not, and then you also get rid of the manual hands-off. Not waiting for your software engineer to pass over to other folk that will do the testing and then will try and put that into staging or production environment. So in the traditional software engineering, we'll look normally at code changes that then will trigger the automated build. We'll have a quick testing, as I mentioned before. You can see very easily if your tests passed or not. And then based on the feedback from those tests, you can iterate with minimal or no waiting time in some occasions. But this is not exactly the same way that it would occur or happen in machine learning. Because in machine learning, we have, first of all, a heavy reliance on metrics. Depending on what metrics you're using, it can be accuracy, specificity. Depending on what your baseline metric is for your model, you might want to optimize in that. We also heavily rely on data visualization because it's so much easier to convey results or highlights or insights from our data through a visual manner. And also, it requires domain knowledge. Whether you're using machine learning for health or for finance or for example, there are a lot of folks doing a lot of amazing work using machine learning for COVID now and for non-profit organizations, but you do need to have some certain domain knowledge to actually extract all of that information, make decisions based on what you're getting out of that. And it also sometimes when people talk about machine learning, a lot of them reduce it to the model, the model seems to be the ultimate goal, but that's actually just a tiny bit of what is actually involved. We have a lot of stuff happening around the development of machine learning, and we also have three we have three pillars being code, data, and environment. And in machine learning, what happens is that we not only have the code change, but if the data changes, it pretty much changes all of your pipeline dependencies downstream. And again, bringing together to the context of the origin of DevOps, we can bring this to the origin of MLOps. When again, the data scientists need to move very fast. Sometimes we are trying, I don't know, 5 different algorithms. We need to do hyperparameter tuning. But we want to use the frameworks that we're using. If we're using Python or we're using R and we're using Keras, PyTorch, TensorFlow, or Caret, whatever it is that you're using, you want to carry on using that instead of having to use a corporation specific machine learning library. We also need it to be scalable. And ideally, we want minimal weight between us being able to do our research and development iteration and being able to taste it in a production-like environment. Again, because there has been so much boom in the whole machine learning ecosystem, the machine learning engineers as well ideally want to reuse the tooling and platforms that they are already using for other software without having to relearn or streamline a whole different infrastructure. They're also concerned about uptime, monitoring. Monitoring is critical for machine learning systems, and as well as reliability and stability. This should be machine learning engineering. So if we reframe this continuous integration loop or process, we have now to keep track again, as I mentioned before, the code and data. And the iteration is actually done not only based on whether a test passed or not, But we actually have to go back and look at the metrics that we are using as baselines to evaluate our models, and improve our models based on those, as well as other outcomes that we have set within our specifications. So how do you get started? And the first thing that people tell me is, I want to start using MLOps, but I don't work in a company with thousands of engineers, or I don't want to move everything entirely to a proprietary system. And you don't have to. Like, that's the nice thing, that you don't have to. You can entirely recycle and repurpose the ecosystem that you're already using. Um, if you're already fostering collaboration through version control systems like Git, Mercurial, if you're using open source development platforms and CI and CD platforms like GitHub, GitLab, Travis, you can still use those. You'll just have to shift the approach a tiny bit so that it fits the goals of machine learning. When it comes to automation, if you're working in a company that is already using, again, GitLab, CI and CD, GitHub, Travis, you can leverage that deployment infrastructure to do all of the tasks that we need to do in machine learning. And the nice thing again is you can use the open source libraries that you love. If you have access to cloud computing, let's say that your company is using Azure or GCP or something else, you can leverage that cloud computing as you've been doing, for example, to do your GPU-enabled workloads. So how would you go about it? In this context, we have the data scientists and the SREs, or machine learning engineers. We have a common environment that is, in this case, GitHub, but it can be anything else again, where your data scientists take care of all of the data processing, and the ultimate goal is to serve your machine learning applications or models into distributed cloud. Let's say that's the infrastructure that your company has. So again, the distributed cloud, let's say it's the realm of the SRE and machine learning engineers, and data is the realm of my data scientist. So as you as a data scientist are working on your code, do check it in as you normally do onto your favorite version control system. And there are libraries out there like DVC. I absolutely love DVC because it not only allows me, so you can integrate that on top of your already existing GitHub workflows. If you're already using Git flow for your development, you can totally integrate that. And the nice thing is that you can also have versions of your models, of your data, if you're using something like Azure Blob Storage or S3 or a local database. You can keep track of those versions and of your parameters, and that is crucial, especially if you're doing very, very fast iteration. So you can keep track of your model, the parameters that you're using, and the performance across those iterations. So you can set that on top of your your version control. So once you push your code that has been modified, or if you modified a single parameter, that should kick off the continuous integration pipeline. And if you're using, for example, GitHub, you can use GitHub Actions. That's going to kick your pipeline. And it can be doing anything like do a training run. Let's say that we actually want to retrain the model, but we don't have to kick that manually. So the CI pipeline has done it for me using the process data that I have. So here we're shifting the context of continuous integration and continuous delivery platforms. So we're not only running tests like unit tests, smoke tests, regression tests, but we are actually leveraging it to do some of the training, data processing. And again, it's all using what would you already like using, like TensorFlow, Python. And you again can set what kind of actions are triggering this. It can be a push, it can be a merge request. And again, you have you tie the version of all of that you're doing to the actual machine learning metrics and results. So again, if you have top data parameters again, you can do that again. If you're using tools like DVC, this is readily available, and you can have a separate file, let's say a YAML file, where you specify your parameters, your CI pipeline kicks in, and then in GitHub Actions, because everything is integrated, but you can do this with any other platform. You can imagine that you can get automated evident reports and metrics to your pull request. So if someone is changing that parameter, you will actually see the performance of your models. And you can even, depending on what platform you're using, extract some information of the compute environment that you were running this in, especially for reproducibility purposes. And again, if you have this makes it, if you have visualizations, you can also display those, and that makes it so much easier for your fellow data scientists and machine learners to review a pull request and do a quick evaluation of what is actually happening under the hood. So once, let's say that you've worked in your code, you've optimized your parameters, you are finally happy with your model or your product or whatever it is that is optimized, it hits the metrics, it hits the requirements. So now the next thing will be rolling out to production. And that's basically the handover from the data scientist to the machine learnings. And instead of having to send things over a wall, it is all done again through your version control and your CI and CD platforms. So then again, let's say that it has been signed off for production. That can be done through a proper sign off or a label, or merging the branch, let's say, into master. So that will trigger again the CI and CD pipeline to make sure that everything is ready, that everything is deployable, that it works as expected in your staging environment, and if it does, you can roll out to the world. And this path is much easier and smoother than a lot of the processes that I've seen in companies I worked for, where basically you had to jump 50 hoops before even trying to put your model into staging environment. And then it turned out that the staging environment was so different to the actual production one that that then you had to restart pretty much the process before putting things into production. And this is just one workflow that I took as an example, but there is way more. There is so many things that you can do. The people that know me know that I love Jupyter. I absolutely love the Jupyter ecosystem and everything they do and everything the teams do. Now there are GitHub Actions, or you can start. People are experimenting a lot with things that they can do within the Jupyter ecosystem. There is this action that, if you are familiar with Binder, as you are pushing your code, it will create a Docker container with all of your development environment, all of your requirements, and it's Binder ready. So if you want to share it with folks at your company or outside your company, it's much faster. Or just to keep track of your containers, it makes it so much easier than having to deal with Docker files and Docker builds yourself. You can also, this is a Azure specific example, just because I work with Azure quite a lot. And you can set up complex workflows where you set up, go from things from building your workspace, training your model, submit the runs, the training run, and deploy the model out in the world. Hamel Hussein from GitHub has been experimenting a lot with MLOps. And I absolutely love this. I've been implementing similar workflows for some projects that I'm working on, and you can get like really nice results and optimize your workflows in a very nice manner. So in brief, MLOps takes a very nice approach where it brings again together the people, the processes, the tools, but that doesn't mean that you have to switch over or drastically change your workflows. It allows you to be much more efficient with the tools and platforms that you already use and love, and basically gives you the opportunity to recycle, mix and match, and pick and choose from your ecosystem. And if any of you would like to access these slides, as I said, they're going to be available after. I just need to click publish onto the link. And I'm going to be hanging around if you have any questions. If you want to reach out, if you want to discuss, hey, can I migrate to an MLOps approach for yourself, or for my company or for my workplace, feel free to reach out. I'll be more than happy to talk to you about it.
Just a sec there. Maya, you're muted on your mic there. Just got to click that a little bit. There you go.
Hello. Thank you. That was excellent. Thank you, Tania. I love your slides. I really love how very diverse the representations are of people. They actually look like the archetypes that I live with, as opposed to ones that show up in a lot of other slides. That was really great. Thank you.
Oh, thank you. Yeah.
Excellent. Look, I've got a couple of questions. Well, I have a couple of questions. So if you were, say, starting MLOps engineer or starting in the field at all, what would be like your top tips for just starting out? What would be the best skills? What would be the best practices? Any specific tools you're thinking of?
Right. So the MLOps, I think area is still very new, and we're still trying to come up with standards and those best practices. But if you've dived into traditional DevOps, I think one of the most important things is doing that mind shift, or from traditional DevOps to machine learning, and actually always keeping in mind that data and code are both are first-class citizens. If also I were to recommend something, think about privacy. I think privacy and security. We tend to put a lot of attention in privacy and security when it comes to our raw data, for example, and then a lot of folks forget about privacy and security throughout the pipeline. So top tip is not only think about automation, but privacy and security across your entire workflow. I have a few resources that I can then share. I can add an extra slide to my presentation with links on different resources for folks that want to learn more about the MLOps, or there are a couple of books, a couple of blog posts that are amazing. So I can add always that slide for folks that might be interested in those links.
Great. Thank you. I think we don't have time for any more questions at the moment, but Tania, you're going to be hanging around in Venulus and letting everybody ask you all kinds of other questions. Thank you so much. We're going to have a very little break before we'll bring on the next speaker. Thanks, everyone.
Thank you very much.